In question number 6, we have to find the complex number z for which z plus 4 upon z plus 4 iota is real and the magnitude of z is root 10. We have to give a form in answer in the form z equals to x plus iota y where x and y are real. Now in the first step, what we can do is write it in place of z, we can write x plus iota y plus 4 divided by x plus iota y plus 4 iota. And now whenever we have a complex number of this form, we can always take the conjugate and then multiply with the numerator and the denominator. But to do that, the first thing we'll do is we'll write it like this, plus we'll take iota common in the denominator. So we'll write it as iota into y plus 4. And now we'll multiply by changing the sign. So we'll multiply by x minus iota into y plus 4 divided by x minus iota into y plus 4. Now expanding the numerator, we'll get x into x will be x squared, x into iota y will be minus xy iota, and then x into 4 iota will be minus 4x iota. Then iota y into x will become plus xy iota, then iota y into minus iota y. So iota y times y minus iota y. This is y squared. Iota is I squared and minus. Iota squared is minus, so we'll get a plus y squared over here. And then we'll multiply iota y by 4 iota. So iota y will multiply by minus 4 iota now. So this will become minus 4 iota y squared. So this will be minus 4 iota y squared. Then 4 will multiply by x, so this will become 4x. And then 4 will multiply by iota y, so 4y iota. And then 4 will multiply by 4 iota, that will become minus 16 iota. And then in the denominator, so we have multiplied the numerator. Now in the denominator, so we can take this as a and this part is b, this is a and this part is b. So we can apply a squared minus b squared. So we let it as x square minus iota into y plus 4 whole squared. Now in the question, an important part was that this, and for this, it is real. It means the imaginary part is 0. So first let's write down all the iota terms. So that will become minus xy iota minus 4x iota plus xy iota minus 4 iota y squared minus 4y iota minus 16 iota. And obviously this will divide by the denominator as well. X square minus iota into y plus 4 whole squared. And this will be equals to 0. So when I cross multiply, this will be 0 anyways. Now we'll take iota common over here and we'll get minus xy minus 4x plus xy minus 4y squared minus 4y minus 16, and this will now be equals to 0. So minus x5 plus x5 cancels. And what else do we have? So we have minus 4x minus 4y square minus 4y minus 16 equals to 0. So we can now write this as minus 4x minus 4y squared minus 4y equals to 16 as well. We can divide the whole term by 4 to write it as, we can divide by minus 4 to make it easier. So x plus y squared plus y equals to 4. So that will become our first equation. And again, we'll have to check because it's lengthy. So we'll have to make sure we haven't made any uh, error with the arithmetics. So this is xy iota. We have minus 4y iota squared. And we have, so let us first quickly go step by step and check if there's any mistake with the expansion. All right, so the mistake I found out was that when I multiplied these two terms over here, so this should have become a plus y squared, so that is fine. And so this y squared is fine. And then I multiply this by, So the y squared term is supposed to cancel out, and I'm just going to check it out over here. So this will be iota y into iota y, that is fine. Then iota y into iota 4. Okay. So iota y into iota 4. Okay, so we got this as 4 iota y squared. This was wrong. This is wrong because iota y into this is 4 iota. So this is basically, this is where I made a mistake with the expansion. This should not have been 4 iota y squared. We are not getting any term as 4 iota y squared. So iota y into 4 iota. Basically, this is iota y into minus 4 iota. Iota square is minus 1. So this would have been a plus 4y only. So this was uh, plus 4y only. This should have been a plus 4y. And are we getting a term as minus 4y iota? Let us check. So yeah, this multiplies by this to get minus 4 iota, and this is fine. So we do not have this 4y squared term as this is a real term, and we are only considering the imaginary terms. So this won't be part of our terms over here. So this will cancel out. And now as this will also cancel out, so we'll get x plus y equals 2, and the signs will change as well. So this was plus 16. When we divide by minus 4, this would have become x plus y. So there's no term over here anyways. So this will also cancel out. So we have minus 4x minus 4y equals to 16, or x plus y equals to minus 4. So that's the first equation we'll get. The modulus of z is given as root 10. So the modulus of z is given by root of x squared plus y squared. And that is given as 10 over here. From the first equation over here, we can say that y would be is equals to minus 4 minus x. So we can write this as x squared plus minus 4 minus x whole squared. Taking the root on both the square on both the sides, we'll get 100 is equals to x square. And the expansion of this is the same as a square plus 2ab plus b square. So this will be 16 plus 8x plus x squared. So x squared plus x squared, that will become 2x squared plus 8x, and 16 minus 100 will become minus 84 equals to 0. Dividing the whole equation by, well, 2. So this will become 4x minus 42 equals to 0. And now, well, we have to solve it quadratically to find the value of x and y. So can we do apply middle term breaking? Let me quickly check. So 100 minus 16, this is fine. X, y would be equals to minus 4 minus x. This is fine. X square plus 4 square 16 plus this is fine. So why can't we solve this through middle term breaking? We should be able to. So this should be 7 and 6. How can we get 4? 8 4s is 32. And okay, I'll have to check this out again quickly. Okay. So again, a very basic mistake. This was a root 10 in the question. I just checked it out. This was root 10 in the question. So when I whole square this will become 10. So these are very small things that we'll have to be careful about. So this will become 2x squared plus 8x, and 16 minus 10 will be plus 6 equals to 0. We divide by 2, we get the values of x. Now we can solve it through middle term breaking. This will become x plus 3 into x plus 1. So the two values of x will be x equals to minus 3 and x equals to minus 1. Now when we take x equals to minus 3, this will be minus 4 minus minus 3. Minus 4 plus 3 is minus 1. And when we take x is equals to minus 1, we'll get minus 4 plus 1 is minus 3. So when x is minus 3, the complex number z will be minus 3 minus iota, because this is minus 1. And when x is minus 1, so we'll get minus 1 and minus 3 iota. So these will be the values for the complex number z. And apologies for the small little mistakes. Well, but they happen, and we'll have to be very careful about these in the exam.